So x cos x dx is a product. So we'll have to use by parts, where we let u be x, differentiate it, we get 1, then multiply it by dx. We let dv be cos x dx, integrate it, we have sin x. Because we know that the formula for by parts is u dv should be uv minus v du. So u is x and v is sin x minus the integral of v sin x and du is dx. So when using by parts, you pick a u that you can differentiate, you pick a dv that you can integrate. So that now we get sin x minus the integral of sine is negative cos. So negative times negative, this becomes plus cos x. And so because we know that we have limits now, so we're saying from 0 to pi over 4 of x cos x dx, this is going to be x sin x plus cos x, running from 0 to pi over 4. When I put pi over 4 here and pi over 4 here, I get pi over 4. What is sine pi over 4? Sine 45. It's root 2 over 2. And then if we do cos 45, again we get root 2 over 2. And then minus, we close. Sine 0, 0, we get 0 here. And then plus cos 0, we get 1. So this becomes root 2 pi over 8 plus root 2 over 2 minus 1. And so we leave it here. That's how we use by parts.
Sir, please explain again.
So to integrate by
Yes,
parts,
because me, I don't even understand.
to
And
integrate,
slow down, sir.
so to integrate by parts, it doesn't matter what you use in terms of angles, because our answers do not really depend on the angles. If you want, you can put 180 over 8. So but I don't know why you're getting it so complicated between radians and degrees. You learned both, so you must understand both. Principle is very easy. Pi is equal to 180. So to integrate by parts, we have a formula. The formula is here. The formula is saying, if you have a product, you pick one of the pieces that are making the product. One you call it U, the other you call it DV. The one you call U, you differentiate it. Now when you call dv, you integrate it. When you differentiate u, you get du. When you integrate dv, you get v. Here we have picked u to be x. When we differentiate, we get 1 multiplied by dx. We've got dv cos. When we integrate cos, we get sine. And then we bring in the formula. U multiplied by v minus v multiplied by du. So u is x and v is sine. V is sine and du is dx. The integral of sine is negative cos. And the negative in between we have cos. Then you substitute the angles, the limits on the right. However, for where there is x and then minus where there is 0. You put x where there is 0 throughout. And you have your answer.
So where is root 2 over 2 coming from?
Cos 45 is root 2 over 2. It's coming from cos 45. Hello.
How do you call this formula?
It's by parts.
Sorry?
By parts, integration by parts.
Oh, in
Sir, why are you differentiating the UV inside the brackets there?
We haven't differentiated the UV. We just copied. It's here. We just combine. The formula says if you have a product of U multiplied by dV, to integrate this, you get U multiplied by V, then subtract the integral of V multiplied by du. So because here we have U and dV, to get du, you differentiate U. To get V, you integrate dV. And then you substitute them in the form.
So where's the 0 plus 1 come from?
So if I have an integral of a up to b of f of x, of f prime, when I integrate, I'll get f. And then I'll have a, b. Then you substitute b where there is x and substitute a where there is x. This is what we call the integral if you have limits. So here we have limits 0 and pi over 4. When you substitute pi over 4 where there is x, you have pi over 4. When you substitute pi over 4 where there is x in sine pi over 4. Pi over 4 is the same as 45. Sine 45 is 1 over root 2. 1 over root 2, if you rationalize it, it's root 2 over 2. That's why we have root 2 over 2. Plus, you substitute where there's x here, you put pi over 4. Because pi over 4 is the same thing as root 2 over 2. So you put it here. Minus, we're now using 0. So you substitute 0 here. Sine 0 is 0, x is 0. So you get 0. Plus, in cos, where there's x, you put 0. Cos 0 is 1. Some more question?
Sir.
Hello.
Where did you get that pi over 4?
In the question. It's here.
Oh, okay.
Sir, look at that formula. Look, the formula says FU dV is equal to UV. I'm talking about that UV. Why are you differentiating it when it's just written as UV? There's no D in front of the U.
The formula says
FU dV is equal to UV. Isn't it? Isn't it what you've written there?
FU,
dV is equal to the UV.
that's not F. That's the integral. The
Yes,
integral
the same integral. Yes,
of
the
U
integral. The
dV is equal to,
is equal UV
you get
minus
U
the
and
integral.
V minus the integral of V du. That is the
Now,
formula. Why are
why
we
are you
using
differentiating the UV? The
the,
UV,
the
this same
VDU?
UV, why are you differentiating it? Because there is no D in front of the UV. So why are you differentiating it? Instead of writing it as X cos X, you're writing it as X sin X.
UV, U and V. Which one is V? V is sine. The question has U and dV. We have to find V ourselves and du ourselves. To find V, you integrate dV. So we integrate cos, we get sine. So sine becomes V.
Okay, I understand now.
Yeah, the answer will still be the same thing, even if you don't understand it. Part 2. The integral of 3x over x minus 2 multiplied by x minus 1 dx.
So
You know?
it's on. So I've noticed that there are some similarities between questions that has to do with substitution and by parts. So I wanted to find out, is there any difference, or maybe I can use substitution method on questions that needs to work with by parts.
And there's a very big difference. The questions that do is substitution. You should be able to differentiate either x, then you get cos, or you differentiate cos and get x, or you differentiate the angle of cos and get x. But none of those is happening here. We can't differentiate cos to get x. Where we use a substitution, if I have the function g multiplied by f, for me to use substitution, it's either when I differentiate g, I'll get f, or when I differentiate f, I'll get g. That's when you think of substitution.
Okay, thank you.
So,
Hello.
Sammy, I have a question on how you put, like how you now replace the pi over 4 and that's 0.
So you start by replacing the one that is up throughout where there is x. And when you are done, you put a minus. And then open brackets. Throughout where there is x, you put 0. Then you close and subtract the two pieces.
Thank you.
Okay, so if I have a fraction to integrate, well, you can't use substitution there because if you multiply the denominator, it's going to be x squared minus 3x plus 2. So if you differentiate this derivative is not in the numerator. So you know you can't use substitution. Again, we can't use integration. I mean, we can't use by parts. Because if we tried by parts, whatever we need to be our dv to be integrated. When we do the mixture on the next stage, it will be more complicated than the way it appears. So the only option that we have here is to break this into partial fractions. So we'll get 3x over x minus 2 multiplied by x minus 1 and break it into partial fractions. So because there are linear factors in the denominator, so we use a over x minus 2 plus b over x minus 1. And then this means we'll have 3x. As I cross multiply, you get a x minus 1 plus b x minus 2. I guess you know that here on partial fractions, you multiply throughout by this denominator here, x minus 2 and x minus 1. So when we say this whole first part by the last thing there, this and that will cancel, then we'll get 3x. That's what we put here. And then
I can't see what.
and then we move to multiply this by this. So this and that will cancel. So we'll have x minus 1 being multiplied by a. And then you do this part by this part. So this and that will cancel, and then we'll have x minus 2 there. And that's what we get. The task that we have now is to get the values of a and b. So we can do elimination where we let x to be 1, so that we can have 3 and put 1 where there's x. Then we'll have a 1 minus 1 plus b 1 minus 2. So this is 3. This is 0 times a, we get 0. And then minus b, because this 1 minus 2, we get negative 1. This is telling us that b is actually equal to negative 3. Well, we go back to the question and now let x be equal to 2. So that we can have 3 times 2 is equal to a at 2 minus 1 plus b at 2 minus 2. This will be 0. So we have 6 is equal to 2 minus 1, which is 1, times a, and we get that. And from there, we're now saying that 3x over x minus 2 multiplied by x minus 1 is actually the same thing as 6 over x minus 2 minus 3 over x minus 1. So instead of us integrating that product, this, because the two are equal, we integrate 6 over x minus 2 minus 3 over x minus 1 with respect to x. Well, if I have such a structure, I can as well decide to separate. I can even write the 6 outside, and so I can remain with 1 over x minus 2 of the x. Minus, I can still write the 3 outside again, so that I remain with 1 over x minus 1 dx. Now, you must all be aware that if we differentiate the ln of g, what you get is g derivative over g the function. That means if I'm to integrate g the derivative over g the function with respect to x, I should retrieve ln of g of x. Like that. That is telling us that if we look at x minus 2 and differentiate it, its derivative is 1. So it means that here we can bring in ln of x minus 2 minus, if you look at the derivative of x minus 1, it's 1. So again, you can put ln of x minus 1, and then you add x. When do I use ln? When I have the derivative in the numerator and the function whose derivative in the numerator sitting in the denominator. Because I know when I differentiate, if they ask you to differentiate ln of x minus 1, what do? You differentiate x minus 1 and get 1, then divide by x minus 1. If they ask you to reverse, you just integrate. So that you get back the question. And that's what we have done here. So every time I have a fraction of this nature, I break it into partial fractions. In partial fractions, I'm more interested in this setup. If I arrive at a situation where x is in the denominator and the power of x is 1, I know that the only way out is to bring in the log function, which is ln. If the power of x is not 1 in the denominator, then use substitution to integrate. Use other methods to integrate. Part 3, find dy dx if y is equal to, if x squared plus y power 3 is equal to 12. Whenever you are given such a question, you decide whether to solve for y or just to differentiate. So to differentiate, just use implicit. So you differentiate x squared, you get 2x. You differentiate y power 3, you get 3y squared. But because the question says find dy dx, it means y is a function of x. So every time I differentiate y, I multiply by dy dx. We differentiate 12, we get 0. The question says find dy dx, so we have to make dy dx a subject. So remain with 3y squared multiplied by dy dx when we take 2x the other side, where it goes as a negative. To remain with dy dx, you divide whatever is being multiplied by dy dx. You divide by that thing. And so this, in this will cancel. So we have dy dx is equal to negative 2x divided by 3y squared. So using implicit, you use implicit when you feel you can't make y the subject. So you differentiate y wherever you find it. Just remembering that every time we differentiate y, once you're done, multiply by dy dx. If you differentiate cos y, you do the same. If you differentiate cos, you get negative sign y. When you're using chain rule, so you come and differentiate y, you get 1. You multiply by dy dx. So guys, there will be questions of such nature as we move in different papers. That is, you should start learning to be fast. Okay, so we're logging out, and then when we get back, we're doing 4A. Hoping we'll also do 4B and C. So quickly, we log out, we join, we start.